Assalamualaikum and good morning class. Today I am Muhammad Adhaka bin Alias and you can call me Sir Adam. Can you repeat again? Sir Adam. So I am going to present to you guys about musical festival optimization. So musical festivals or other festivals can quite be challenging because we will face a lot of problems such as managing profit, managing budget, managing the time, budget time, and also a lot of more. But today, for my topic, we will talk about we'll talk about simply about something. Let's look at the content first. So for the first one, introduction. Introductions. So I will simply brief you about how about the musical festivals, give you about the equation we will use. For the second, the scenario. So if I give you the scenario, you can quite imagine the scenario itself, which is how it happened, how it going to be, how will we face the problem. So it can help you guys to imagine the problems so much better. For the third slide, the linear equations. The linear equation, which is we are going to make stage time. For this one, I will brief it more smoothly after that. For the fourth, the budget, which is we are going to use equation linear inequality. For the fifth, the profit, the profit from the music festival, which is we are going to use quadratic equation. Do you guys remember, like x square 2 x exponent 2, yeah. And the sixth, analyze and interpretation, which is we are going to analyze more with details, and we are going to interpret about some the problems with the problems, and we can, after that we will make the conclusion from all of it. So let's go. For the introduction, mathematics helps solve real-life problems using logical models. As you know, real-life problems such as building bridge, constructing roads, managing events can quite challenging. So mathematics quite important for managing and to solve the problems, and this can be handful. This can be handful for those who have used it. So linear equation, for the linear equation for constant rate change, like scheduling, like will constant goes up or goes down, it will still constant. For the linear inequality, for limits such as budget or safety, where for example, we want to limit, or we can limit the budget we want, or the other one, we want more of that, or just in case. Or other than that is quadratic equation, which is we can find break-even points, maximum and minimum result, and which quite helpful for handling events such as musical festival. So for the next slide, scenario itself. Are we going to talk about the scenario? The scenario is 2-day outdoor event with local and international performers, which is local local and international performers will come to the place, which is like in Malaysia, can perform their music or their band to the crowd, so they can gain popularity at there. So the music festival is the art, culture, massive crowd, which is it is quite necessary for us, because music is not just entertainment but also art and culture. So most we will we will face a lot of problems. So math can be a secret tool to solve the challenge. For the next slide, goals for this musical festival is to attract tourists, which is the tourists from the international or local can go to the event to support the performers, so they also can entertain themselves and quite give a lot of profit to us too. Other than that, it can also promote talents too, which is talents that are not given a chance to perform their talents, to perform their talents, can try um, to go to the musical festival and show their talents to the crowd. So they will gain popularity, and also they will can gain popularity at there, which is quite helpful for them. Lastly, we can entertain audience. So the audience, which is the crowd at the musical festival, can get entertained by the performers, and this will help a lot for making our profit, um, for entertain the local, the tourists, and a lot more. Other than that, the challenge we will face for the musical optimization time scheduling, which is we are going to manage the time for the performance, which is we are going to use linear equation. For the second one is budget. The budget we are going to use the linear inequality, so the budget will not exceed the limit. Other than that, we also going to talk about the profit, which is we are going to use the quadratic equation, and this help to make the problems can get much more easier. The next slide, with stage time. The equation we will use is 45x plus 30y, 30y, sama dengan for 418, which is x is main stage show and y in this stage show. The total performance times is 489 minutes, which is we convert it to the hour is 8 hours. So first of all, we are going to convert it to the y equal to mx plus c, because it is much easier if we simplify it, and we can make it easier to plot the graph and the others too. So 30y. So in this case, we are going to the 30y equal to negative 40x plus 18, which is y we divided with 30, and we will get y equal to negative 3 per 2x plus 18. So for searching the plot graph, we are going to we're going to search for the y-axis intercept and x-axis intercept. So first of all, we are going to y equal to negative 32 per x plus 18, and we change the y with 0, and we will get 18. Sorry for the name, which is 32 per 3, and this 32 per 3, which is in the around 10 and 12. So in this case, we are going to add this, and after that we are going to make a line from it, which is here. So this is the graph we can see. After that, okay, so this is the actual graph that I have get from the website, which is Algebra. So do you guys understand, kids? Yeah, sure. Okay, so for the next slide, which is budget. For the budget, we are going to use linear inequality, which is at here I have shown you the equation, and x equal to mean ratios and y equal to index ratios, which we are going to keep the total cost under the 15,000, which is we doesn't want to exceed the budget, but if we is on the point, which is 15,000, then it is okay, it is good. So we are going to make a graph from it, and to make it simple and to make it simple and understandable, we are going to convert it to y equal to mx plus c, which is you can look at 800 less than 2, and we are going to get this. Yeah, this. Yes. So for the graph equation, we are going to use y-axis ratio, which is 2, and x-axis is 2. So for this, we same as the linear equation, we are going to search for y-axis intercept and also x-axis intercept. So for the first one, which is y, so y-axis intercept, we have no, because in the equation the y-axis has already shown in the equation. So y equal to and for finding x-intercept, we are going to convert the y with 0 because we are going to intercept the y, and for that, which is we are going to plus per 4, and we will get x equal to 10. And for this one, we wait, let me just look at for a second. And for this, we are going to look at the x as the first, which is the x at the 10 and the y at this area. This area. And after that, we are going to make a line from it, from the plot. And there we go. We have get the graph from the linear inequality. And I forgot one, because it is in this way, so we need to logarithm at this part, because it is going to at the kiri at the left. And there we go. We have get the graph, and we can look at for the actual. And yes, as we can look the graph, this graph I get from the Algebra. Yes. And for the last part, which is the profit. So do you guys remember the profit, the equation? What will we use about? What we will use? Yes, quadratic equation. For this one, the quadratic equation is, as you can see, the model. This one. This is the quadratic equation that we will use, as you can see, which is A is a t cap plus from it. And for the introduction part, we are going to solve for the break-even point, which is it is in the like this, where this is x and this is the graph, and it is in this area like this. So the break-even point, we can look this we convert the p with 0, so we can search for the x-axis intercept. And after that, we simplify it to the more simpler equation, which is we have to divide it with 20. And after that, we are going to factorize it, which is a negative 13 and a negative 15. And after that, we will got the first break-even point, which is equal to 13, and the second break-even point, which is 15. So for graphing the equation, as you can look, to graph the equation, wait, let me just okay, negative a2 plus 18a negative okay, And for this, we are going to use the x-axis, which is we are going to use 10, and for the y-axis, which we will going to use 15. And for that, we are going to search. We will search the y first, and this for the 20 negative 2 plus 20 negative 20, and we will get negative 300, which is this. And after that, for the second, so as we know, the 13 the y will be 0 because it's the intercept, the x-intercept, so it will be 0. And for the 14, we are going to solve this, which is plus 14, and we will got 100 of that. So with this, and the last is 16, which is we are going to solve this, and we will get negative 100. Okay. After that, as we get the plot, and we can plot as we can get the titik, and we can plot the graph much more precisely. For the first one, 20, which is at this point, and this, and this, and this. So we're going to this and this. As we can see, we have successfully plotting the graph, but maybe this is not the perfectly, because it is kinda hard to draw it in this position. So and as the result, and the graph we have drawn earlier are correct, as we can see. Do you guys understand? Okay. So to the next slide, which is analysis and interpretation. The linear equation give a balanced time between both stages, which is in this stage and main stage, and this help so the balance, so the in the performance and the main performance can balance, can perform with no harmful. And for the linear inequality, we can maintain the spending within the budget. So we don't want to exceed the limit of the budget, so we must constrain the budget from the at the low in the value. And for the last one, quadratic equation, which is we want to find ideal ticket price from the musical festival. As we know earlier, the 13 we will get loss of it, and the 15 we will also get we will also lost some profit of it. So the profit we can gain, which is the maximum we can gain, we will get from the plot and the graph, and this help a lot for this. All models reflect real-world decision making using algebra. So remember, algebra is important in daily life and also in real-life problem. The last one, conclusion. Mathematics ensure efficient and organized event planning. So the events can run more smoothly, and no more problems we will face in the future. For the second one, linear model structure performance schedules. And linear inequalities keep spending realistic and controlled. So the inequalities can control our budget, let's say others too, not just budget, but we can control it more precisely, and we don't want to over the limit. And quadratic models maximize profit. The profit itself or the other things, because math and algebra is widely open to use, and this mathematical modeling helps a lot for solving problems. So math plus creativity equals to successful music festivals. And that's all from me. Okay, bye.